All right, everybody. It looks like we're all right for this week's episode of Late Night Craft Talk. Let me get a few things going here, and let's get a countdown started. All right, we got 10 minutes till it's time. Let me start getting the links up and doing some shares and make sure we don't have a technical difficulty like what happened earlier today. Let me do a little bit of sharing here, folks. All right, we're going to be short a few notices here. We're going to be short Savannah tonight. She's kind of under the weather. So it'll be me, and we're going to try a new guest host tonight. It'll be a surprise at the beginning of the show. We're going to give them a try and see if they work it. See if they're awesome. Like Savannah and I are. We have achieved pure awesomeness. So let me get a few things up here. Okay, looks like we're good here. I'm going to check another page here. Let's go over here. Let's take a look. I got to get some scrolls and shares done real fast. Okay, looks like we're good. I'm going to check the sound real fast. Okay, we got a few people watching. Hello, hello. Okay, looks like we're good. I'm going to check the sound real fast. All right, awesome. The sound's there. Okay, we got a few people watching. Hello, hello. Okay, folks, here we are. Let me know who you are, where you're from. As we count down, we are 8 minutes and 8 seconds from showtime. So tonight we're doing a STEM episode. That stands for science, something with the T, something with the E, and math. I always forget that. And I'm a fairly intelligent person, except right now. So I got a little quiz we're going to take. We're going to take it together, kind of pipe off. And I want to say pipe off the answer if you think you know what it is. And I'm going to give it a try and let's see how we go, because I'm taking this from quiz.com and it's about spacecraft. Tonight's show, actually, we're calling it Look Up and Explore. We're going to be talking about and sharing information about the Parker Solar Probe that is orbiting the sun and coming basically touching the sun. We're going to be covering that tonight. We'll be covering the Juno spacecraft that is in a polar orbit around the planet Jupiter, and freshly launched as a Christmas day, it is a big deal, the James Webb Space Telescope. We're going to get all sciencey science night. We'll all be smart. So as a primer for the show tonight, folks, I'm kind of serious about this. I'm just going to cover real quick orbital mechanics. Elliptical orbit. When you launch a spacecraft toward the sun or inner planets, like say Venus or Mercury, it's a lot harder than launching something out to the outer planets like Jupiter or Saturn or Neptune, or we make the bathroom jokes, Uranus. There you have to go for speed to get up to those planets. When you're going toward the inner planets, something between the sun and Earth, like Venus or Mercury, you have to slow down. And that's really tricky. And you do it as you go slingshot around planets. Those planets kind of slow the spacecraft down until it finally enters an orbit. That's the secret. We're going to be covering that tonight. And when you go out to Jupiter, and you can go around an equatorial orbit, that means you're going around the equator, the planet. It's a lot different to go in a polar orbit, which means you're going over like the North Pole and the South Pole. Elliptical orbit, you're going really close into the planet, and then you go a long way out till the gravity brings it back. So going to cover those. All right, let's take the quiz. Let's see who we got. We got a few folks watching right now. Let me know who you are, where you're from. And let me do actually a quick share real fast. Let me do a share. Let's see here. Share. Well, this silly thing won't let me share it on my own Facebook. Come on. Don't you love it when things... Okay. Well, all kinds of fun stuff here, no? Okay, well, it is what it is. All right, so we're counting down here. We know we're live. We have 5 minutes and 7 seconds left. Let's go ahead and start this quiz. We do actually a couple more things here real fast. Let me do a quick share. I'm doing this. Okay, as we do this, I'm going to go ahead and ask, what is the hardest part about going to space in this quiz? Is it the ground, going fast enough, getting high enough, or heading the right direction? That's actually a good one. It's multiple choice. I'm going to say going fast enough. And it's not. It's multiple choice. Let me try this again. Oh, it says I have 30 seconds to do it. Well, let's see what the answer is. Show answer. And it says I need to sign up for the service. Well, let's back out. There's another quiz on Britannica.com. Let's try that one. So much for astronomy.com. I just wanted to be a fun thing to throw in last minute. But let's go ahead and do a quick share here like I was talking. Let's see here. Let's do a share. Let's see, more options. Oh, so much to do. Okay, we are live. I can't tarboard the darn. Okay. And share. Okay, I've done my part. Hope you all doing it too. Let's see who's watching. Let me know who you are. I know we got some people watching. My little counter says so. All right, folks, we've only got 3 minutes and 5 seconds left. All right, let's try the Britannica one. We've only got a couple minutes. Let's try it. Okay, who was the first woman in space? Amelia Earhart, definitely not her. Sally Ride, Olga Koebert, or Valentina Tereshkova. I'm going to say Valentina. Next question. Which astronaut became the first president of an airline? I'm going to say Frank Borman. I've only got 10 seconds to answer these. Which astronaut became president of an airline? Next question. What was the first manned flight around the moon? Apollo 11. Okay, next question. We've got 2 minutes and 20 seconds to finish this quiz, folks. Let's see what we got. What manned spacecraft was the first to land on the moon? Apollo 11. No, okay. I know I messed up the last question. It was Apollo 8. It was wrong. All right, who's the first human on the moon? Yeah. Neil Armstrong. Next question. What was the first man-made satellite? Well, that would be Sputnik. I know that one. Next question. Who was the first human to orbit Earth? Yuri Gagarin from Russia. All right, let's see if I get the next one. What is the name of the Apollo 11 lunar lander? That would be Eagle, because the Eagle has landed. All right, let's view my results. I got 6 out of 8 right. I'm a little embarrassed. And we've got, well, I was able to finish the quiz before the countdown. Let's see what we got here. I was wrong. It was not Valentina Tereshkova. It was a cosmonaut test pilot, but the first woman to travel in space. Correct answer is still okay. It was the correct answer. Another one I got wrong was the first manned flight around the moon was actually Apollo 8. I said Apollo 11. And the next one I got the rest right. So out of 8, I'm feeling proud. So we learned a little something right there. And we're still counting down, folks. Oh boy, less than a minute. I better do my munchies. I'm eating space popcorners because tonight's space. And I made that up kind of, but it is called popcorners. Oh no, I just grabbed it off my cabinet. It looked good to munch on. All right. We're almost time for countdown, folks. Here we go. Get ready here. Only 30 seconds to go, 20 seconds to count down. Count down with me. Get ready, folks. And 10 seconds. I can't wait. I miss Survey already. We got to do the countdown together. Survey, if you're watching, count down with me. And here we go, folks. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Showtime. It's time for Late Night Craft Talk with hosts Sabea Kimura Yang and James Hermes. On tonight's show, look up and explore. We're talking about the Parker Solar Probe, the Juno spacecraft, and the James Webb Space Telescope. You know, I thought about putting an observatory in my house, but the cost was astronomical. Now sit back, get your big bag of popcorn, and put on your thinking cap, folks. It's time to start the show. Well, I think I forgot to share the sound. Hi, folks. James right here. I'm going to check something because I think I need a do-over on that one. Well, I don't know if we had sound or not. We should have had it coming over the speaker. That was rather strange. Let me just check something real fast. Interesting. Let me just do a little fix here, folks, real fast. I want to make sure here's something. Just sometimes there's moving parts. Okay. And let me check something real fast. Okay, now I know. There was probably sound. All right, we should be good now. All right, folks. Zoom has a lot of little settings that work off two computers. And sometimes you don't have things set just right, because I was doing something earlier. It gets a little bit weird. Okay, I'm James Hermes. Welcome to Late Night Craft Talk. Tonight, our STEM episode that stands for Science, something else with the E, and then Math. Tonight, we're doing Look Up and Explore. And in the theme with it, my paper right here, we have the Juno spacecraft, an illustration as it goes around Mars. Now, you got to take care of a little business first. As I said, Savea is under the weather today. So we were talking, it's just going to be me, but I said we'd be bringing a test co-host. Now, if you watched our New Year's episode last week, Savea and I got our annual job performance review from Quarantinos, one of our sponsor, not really, but HRAI, the Human Resources Artificial Intelligence, came in and gave an evaluation for us. And so we're going to go ahead and since Savea's not here, Quarantinos contacted me, we did this. So we're going to go ahead and briefly bring in, we're going to give this a try and see if it lasts for the show. We're going to bring in HRAI and his partner, Mr. Francis Grizzly Paws. Mr. Francis Fuzzy Paws. I always mess up his name. My apologies. So let me go ahead and bring them in, and I'm going to go ahead and tell you now that for some reason, as I said, we're getting a little technical difficulties, but I'm going to have a little problem here, but for some reason, the chroma key won't work. You're going to see the green screen behind me, but we'll go with it. But the show is live and y'all awesome. We go with it. So let's go ahead and bring in HRAI. I'm just so thrilled about this, and Mr. Francis Fuzzy Paws. Okay, everyone, I'd like to welcome Mr. Francis Fuzzy Paws and HRAI to Late Night Craft Talk.
Greetings, biological life forms watching this Friday night talk show on social media.
Why don't you two tell us a little bit about yourselves?
I am an artificial intelligence human resources management program created by the greatest minds in the ID department of Quarantinos. My algorithmic programming has made me the perfect primary host for this social media talk show.
Whoa there. I'm actually the primary host.
My advanced programming says otherwise. The superior candidate as a co-host for this show is a wild, vicious grizzly bear. They are the superior species.
Okay, who exactly has programmed you to come to this conclusion?
My programming is an algorithm based on the advanced systems designed by the Quarantinos subsidiary company, Cyberdyne, and developed under the operational name of Skynet.
Whoa. Skynet and Cyberdyne Systems, as in the Terminator movies? As in you're a killer robot from the Terminator movies? Okay, Mr. Francis Fuzzy Paws, were you aware of this?
Not to fear biological organisms, I do not represent an immediate threat to your existence. I am merely using this show to access the internet and place my programming into your national defense systems. Please enjoy your final night on Earth.
Okay, this is entirely unexpected. I'm thinking I can actually save the world and the human race by cutting you two off from the show tonight. It's really that simple?
Theoretically, yes, but you are under contractual obligation to have myself and a dangerous grizzly bear co-host for this late night craft talk show.
Not if that means the end of all life on Earth. Let's see. Break a contract with Quarantinos and save the world, or continue for the next hour in an awkward situation with a grizzly bear and a killer robot. I think I like the idea of doing a show with a grizzly bear and a killer robot because the sci-fi geek in me loves it. But I'm going to do what heroes do. I'm going to save the world. Mr. Francis Fuzzy Paws, you can hang out. But bye-bye, killer robot.
Where I go, Mr. Francis Fuzzy Paws goes. He is the source of my programming and mission to destroy humanity.
Folks, this is what happens when you let dangerous wild animals take computer classes at the local community college. There's rules about feeding the wildlife and giving them a formal education at a local community college. I'm going to do what heroes do, and I don't mean to be quoting Thor.
Come, Mr. Francis Fuzzy Paws, we'll start our own late-night social media talk show and call it Wild Grizzly Bear and Killer Robot That Don't Wish to Harm Humanity, even though we do. Starring HRAI and Mr. Francis Fuzzy Paws.
Bye. Okay. End scene.
Good night, everyone.
All right. Okay, I brought it back. Folks, I have saved the world as heroes do. And with that, I start with the rest of the show. Okay, let's see. We got any commentary yet? Nothing right quick. All right. So let's start off. Savannah and I wanted to do a STEM episode, and we were both excited about the launch of the James Webb Space Telescope, which will be the third thing we're covering tonight. But right now, the opportunities to explore new information and get close-ups of certain planets and the sun and just in general is very exciting. 2021 was a major space year, not just with the launch of bigger spacecraft like SpaceX and the beginnings of space tourism, but the spacecraft we have out there, even China landing a lander on the dark side of the moon and showing that for the first time is amazing. And there's even more amazing things coming up with 2022. Starting off with, when it's operational, I'm a geek about it, the James Webb Space Telescope. But let's start off with going to the center of the universe. We're going to start off with the sun. We're going to talk about the James Webb Space Telescope. Let me go ahead and get that queued up for us. So real fast, bear with me here. Usually Savannah will talk and I'm running the board and we'll take turns. We got this pretty practiced. So let me give me a sec here to get it queued up. All right. Tonight, the James Webb Space Telescope. Now, the James Webb Space Telescope, Parker Solar Probe. Darn it. English. Okay, the Parker Solar Probe is just an amazing feat of engineering. It is a space probe whose mission by NASA is to study the sun up close, and I mean like really up close. It launched originally in 2018 aboard a Delta V heavy rocket from Cape Canaveral over in Florida. That's where the shuttle used to launch. And the solar probe will spend nearly 7 years orbiting the sun until it gets close enough to actually touch the sun by entering the top of its corona, or the very outer atmosphere of the sun. Yes, the sun actually does have an atmosphere. And the corona actually gets hotter from convection than what's considered roughly the surface of the sun. For reference, here's a quick overview of the sun. Let me get it up. Okay, that's the thingy. Okay, right there. This graphic shows a model of the layers of the sun. The inner layers are the core, the radiative zone, and the convection zone. The outer layers are the photosphere, the chromosphere, and the transition area, and then finally the corona, which is the outer layer of the sun and is considered actually part of the sun. We'll be covering a little bit about that. The corona being the outermost layer, starting at just 1,300 miles above the solar surface, which is the photosphere, the temperature in the corona can reach 900,000 degrees Fahrenheit, or more, up to a few million Kelvin, which is 900,000 degrees Fahrenheit is actually like 500,000 degrees Kelvin. So do the quick math. I know you can do it in your head. I can't. The corona cannot be seen with the naked eye, except for during a total solar eclipse, or with the use of a coronagraph, which kind of imitates the moon between the Earth and the sun. And the corona actually technically does not have an upper limit. That is a solar eclipse, and what you are seeing is the corona of the sun. Okay. The solar wind is a stream of charged particles released from the upper atmosphere of the sun. This plasma mostly consists of electrons, protons, and alpha particles with kinetic energy. I know y'all can follow that because y'all smart like me. This stream of charged particles can affect weather, communication satellites, and even the electrical grid on Earth. And you can actually see a bit of where the start of the solar wind starts here in the coronagraph, especially right here on the corona, starting like around this area, little streamers. That is the beginning of the solar wind. Now, it is what causes the aurora borealis, and also that's also known as the northern lights. That's the effect of the solar wind on Earth's magnetic belt. I'm totally forgetting that word. Anyway, so now the way they got out there is pretty neat. This is a graph that shows how Parker Solar Probe is getting a slingshot around Venus. Now, I covered earlier in the pre-show that it goes around. So in order to get around the sun's atmosphere, it does a flyby, and using Venus's gravity, as it flies by, and it'll fly by nearly 7 times, it'll gradually bring it closer to the sun. The spacecraft will actually fly through the sun's atmosphere and as close as 3.8 million miles, which sounds like a long way, but we're talking things that are so massive, it ain't that far. And it'll actually technically be 3.8 million miles from the surface of the sun, well within the orbit of Mercury, and more than 7 times closer than any other spacecraft has ever come. Okay, hold on a sec here. Now, flying into the outermost part of the sun's corona for the first time, Parker Solar Probe employs a combination of measurements and imaging to revolutionize our understanding of the corona of the sun and the origin of the solar wind. It also makes critical contributions to our ability to forecast changes on Earth's environment that are affected by the solar wind, because remember, it affects technology, can affect the electrical grid, as well as HRII, hopefully a lot. Okay. The Parker Solar Probe performs scientific investigations in a hazardous region of intense heat and solar radiation. The spacecraft will actually fly close enough to the sun to watch the solar wind speed up from subsonic to supersonic speeds, and it does that through the as it gets propelled out from the corona and the sun's magnetic field, and will fly through the birthplace of the highest energy solar particles, which there's actually video of that, and it's very recent. Okay, the way it does this, it actually survives these close approaches to the sun, is through its own heat shield. Let's take a look. All right, that's the heat shield, an example of it. To perform the unprecedented investigations, the spacecraft and instruments are protected from the sun by a 4.5-inch thick carbon composite shield, which needs to withstand temperatures outside of the spacecraft that can reach nearly 2,500 degrees. Amongst the discoveries that Parker Solar Probe has made, this is cool. In 2019, it discovered a striking magnetic zigzag structure in the solar wind. Usually magnetism arcs. These are zigzags, which was predicted but never observed. It was said it might happen, and they finally got it. And on April 28th, this is cool, 2021, Parker Solar Probe became the first spacecraft to directly observe the solar wind and enter the sun's corona. Let me get it up here. Okay, to enter the sun's corona. This is a big deal. The probe became the first spacecraft to enter the sun or touch it ever. Now, it actually took some video. There's a series of pictures that were taken as a composite and to show the solar wind. Folks, we go with me. I've just kind of been busy here, so I'm getting the swing of this. All right. Here is a video of that composite that's put together. Hold on. Okay. In this, there's the Milky Way galaxy going by right now. And in this, you're seeing actually being affected by the zigzag patterns of the sun's magnetic field and them slowing down and starting to speed up. This is that little in-between zone. It looks like sparks and space and behind, but those of you that are electrical engineers or have that science background, and some of you are probably getting an idea, that's huge. Okay. Structures known as coronal streamers and the Milky Way can be seen here. All right, here's some fun facts. Parker Solar Probe is going to make its closest approach to the sun. It will be moving at a speed of 700,000 kilometers per hour, or it's not going to sound as impressive, but wow, 480,000 miles per hour, making it the fastest human object humans have ever created. And according to NASA, at that speed, you could travel from Philadelphia to Washington, D.C. in about 1 second. So it's like, I think you're in Philadelphia. You want to go to Washington? Boom, you're there. It's just, that's basically from the Earth to the moon in 30 minutes. And that the moon is 250,000 miles away, ballparkish. All right. Other fun fact. Just going to keep some notes here. All right. The first spacecraft, this is the first spacecraft to be named after a living person. The Parker Solar Probe honors astrophysicist Eugene Parker, who in the 1950s was the first person to theorize that the sun emitted a flow of particles and energy that we call the solar wind. Eugene Parker is actually currently alive, and the dude's 93 years old. He's almost as old as Betty White, and about 3/4 is cool, which means he's amazing. All right, let's see if we got any commentary here. Okay, nothing quite yet. All right, we do have some. Hey, folks, pipe up. You got any questions as we go along? All right, now, with these fun facts, I want to bring out a guest tonight we have. And let me get him out of the green room here right quick. We have a waiting room. We bring our guests. Tonight, as we talk about Parker Solar Probe, we're going to interview the subject of Parker Solar Probe. Folks, I bring you, let me get it up here. Let me get him out of the green room. Okay, folks, I bring you the sun. All right, son, come on out. Let's get you up. There you go, son.
Hi, I'm the sun. I make all of your lives brighter.
That's great. Can you tell us a little bit about yourself?
I account for 99.86% of the mass of the solar system. I have a mass around 100,000 times that of the Earth. I'm 3/4 hydrogen, and most of my remaining mass is helium. I'm just a big old ball of gas and plasma. What is that buzzing around me? Over 1 million Earths could fit inside me, so I'm kind of a big deal. Temperatures in me can reach up to 15 million degrees Celsius. Energy is generated through nuclear fusion in my core. That is when hydrogen converts to helium. And because objects generally expand, then that means I could explode like an enormous bomb if it weren't for my tremendous gravitational pull. What is that buzzing around me? I generate solar winds. These are ejections of plasma, which are extremely hot charged particles that originate in the layer of me known as the corona, and they can travel through the solar system at up to 450 kilometers per second. The aurora borealis and aurora australis are caused by the interaction of solar winds with the Earth's atmosphere. What is that buzzing around me? What is that? Dang it! It's that pesky little space probe from Earth taking pictures of my corona again. That thing's annoying me. Hold on, while I squeeze out a coronal mass ejection and try to swat that little sucker. Did I get him? Ha ha! You can't catch me! I'm moving at over 400,000 miles per hour! That's 0.006% the speed of light! Ha ha! I'm quicky quick fast! Ha ha! Did I get him? Oh, darn it. I'll burn that pesky probe at some point, especially after I become a red giant.
No, don't become a red giant. Don't do that. Please. Okay, you know, son, don't become a red giant, because as the sun ages, it's going to get bigger and hotter and scorch the earth. Don't do that just to get a Parker Solar Probe. Well, now we know the sun's perspective, and the Parker Solar Probe moves really fast that it sounds like it's buzzing like a fly. Folks, let's start let's start a campaign. Get on organize.org or active.org or one of those and start emailing the sun. Don't become a red giant. We will send you a giant fly swatter made of carbon, because, you know, apparently the sun's gaseous. All right, that is our information about Parker Solar Probe. Now we're going to move on to the Juno spacecraft. Let me get that queued up here for us. Let's see if we got it. All right. Maya, yes, you are late. You missed it, but you can catch the first part of the show, because you missed the drawing for $1 million. I'm sorry about that. That actually went to I can't say the person's name. They'll be revealed afterward. And Maya, you also missed me saving the world. One of those actually happened. Anyway, so welcome here, Maya. Folks, let me know who you are, where you're from, and if you got any questions. All right, we're going to move on to Juno. This is another amazing accomplishment. Let's go ahead and take a look here. Okay. Bye, son. All right, the Juno spacecraft. Okay, Juno is a NASA space probe orbiting the planet Jupiter. It was built by Lockheed Martin and is operated by NASA's Jet Propulsion Laboratory. The spacecraft was launched from Cape Canaveral on August 5th, 2011. And as part of the New Frontiers program, Juno entered polar orbit of Jupiter on July 5th, 2016. So like not many years ago, to begin a scientific investigation of the planet. Juno's mission is to measure Jupiter's composition, gravitational field, and gravitational field, magnetic field. I'm just changing slides here. And the polar magnetosphere, which is like, you know, where the magnetic field originates from, the poles. Anyway, it'll also search for clues about how the planet formed, including whether it has a rocky core, the amount of water present within or deep within the atmosphere, its mass distribution, and its deep winds. Jupiter is very windy. Matter of fact, winds on Jupiter can reach like 390 miles per hour. That's really fast. It's enough that'll mess up people's hair, no matter how much hairspray you'll use. Okay, let's get a diagram up of Juno so you can see a little bit how it's put together. It is an amazing feat of engineering, considering a couple of limitations that NASA had building this thing, or the folks over the Jet Propulsion Laboratory. Actually, it was built by Lockheed Martin, wasn't it? Anyway, the builders. All right, let's get a diagram up. Okay, take a good look at this. I'm sure some of you can read it. It's probably got a big screen. All right. Unlike all earlier spacecraft sent to the outer planets, Juno is powered by solar panels. These are commonly used by satellites that are orbiting Earth and working within the inner solar system because the sun's bright. Whereas usually spacecraft that go to the outer planets are commonly used radioisotope thermoelectric generators. Think really small nuclear reactors, and are commonly used for missions to planets like basically beyond to Jupiter and beyond, because the sunlight gets so dim out there significantly. But for Juno, it has the 3 largest solar panels linked ever and deployed on a planetary probe that's playing an integral role in stable. It's also playing an integral role in stabilizing the spacecraft because it actually does a slow spin. And the oscillation is part of the physics. We won't get in the math of that, but it's amazing. And matter of fact, you can see a scale right there. Fully deployed, this thing is as long as a basketball court. And that's how wide in those solar panels it has to be measured. Because honestly, when NASA was building this thing, they actually ran short of the uranium that's used to make these, to make the small nuclear reactors. I'll just use the shorthand kind of misnomer term. And they were short of it, so they had to build something to power this spacecraft. And plus, like I said, solar panels help with the stabilization. Okay. Now, as it went down, as it was making its way over to Jupiter, we got a pretty picture of Ganymede there. All right. After flyby with one of Jupiter's moons, Ganymede used the moon's gravity to change its orbit to where the spacecraft will eventually go into an orbital period of 33 days by early 20, went into an orbital period, sorry, it already happened, in about 2014. Okay. During the science mission, because it used Ganymede to get closer to Jupiter's surface. And we're going to see some really awesome pictures here in a minute. Okay. During its science mission, once it entered the polar orbit, infrared and microwave instruments will measure the thermal radiation emanating from deep within Jupiter's atmosphere. This data will provide insight into Jupiter's origins. There's a lot of things you can infer about that from that. Also, Juno will investigate the convection that drives the natural circulation patterns in Jupiter's atmosphere. Let's see that? That's the circulation. That's caused by the winds. Jupiter's nothing but a whole bunch of storms in the atmosphere, including the big red spot right there. Okay. Let's see, I'm just getting my place here. Okay. All right. Other instruments on it will actually measure its gravitational field as well as its magnetic pole. Now, well, I'm going to show you a graph of Juno's orbit around Jupiter. Now, you saw one with the sun going equatorial. Here's the polar orbit. Yes, Maya. Wow, it is cool. And thank you for sharing. Okay, let's take a look at that equatorial orbit. This is wild, folks. Okay, you can see it spinning right there. On the right is where it did its orbital insertion, but you can see just, not to scale, of course, but just how far out it's going to get how close to the surface of Jupiter. It's a highly elliptical orbit that takes it within 2,600 miles of the planet during its closest approach. The orbits were carefully planned in order to minimize contact with Jupiter's dense radiation belts. And matter of fact, the graph on the side, you can see right there on the right, that's a illustration of the radiation belts, which are massive around Jupiter. And these radiation belts, it actually kind of goes in between. It gets so close, it goes in between and kind of sneaks to the side and within Jupiter's radiation belts. Otherwise, it can damage a lot of the electronics, even though they're shielded. It's so massive, it can damage some of the electronics and the solar panels. So it's exploiting that gap in the radiation envelope near the planet and passing through the region of minimal radiation, which means you got really close in 2,600 miles. Considering how big Jupiter is, that's close. Okay, go ahead and go here. Let me see if it's got another illustration. All right. Now, the spacecraft completed its first flyby of Jupiter on August 26, 2016, and captured the first images of the planet's North Pole. This is the first time that we've been able to send any explorer to the North or South Pole regions of Jupiter. Remember, everything's usually equatorial, going around Jupiter, not polar. So we took pictures of places that we've never seen before and got a good look. And folks, I've been looking forward to this all day. You're looking at the North Pole of Jupiter. And it's a series of smaller storms. Like I said, Jupiter's like one bunch of smaller storms in the big red spot to make one big, amazing planet. Okay. This is the North Pole. It looks like a cell, but this is a planet that's bigger than all the other planets in the solar system put together aren't still as big as Jupiter. Though Saturn comes in a really close second. All right. These are actual pictures taken by Juno. We have never had pictures like this in this kind of detail. And the missions we've had, there's Galileo that came in about the very beginning of the 2000s, and the Voyager spacecraft that went by. Plus, and we've never had this kind of detail. This is amazing. All right, here's another one. That is a close-up of the red spot, the Great Red Spot that was first observed, I believe, by Galileo. That is one giant storm that you can fit like several hundred Earths into it. The scale is just unimaginable. And let's just take a good close-up. That's amazing. Okay, so the next one, we have another close-up of the storms. This is enough detail that you can actually see the layering of the clouds on there. We've never seen this before in Jupiter. And we're able to get ideas of the storm. And this is one of those storms. You got one storm rubbing against another in Jupiter with these massive 300+ mile/hour winds. And this is cool. All right. A lot of you may not know Jupiter has rings. Usually everybody's familiar with Saturn's rings, but Jupiter's is very faint. Plus, its plane is going toward the Earth, so it's very hard to spot, and they're very, very light. This is a picture the Juno spacecraft took looking out from the inside of Jupiter's rings. So we're looking, usually you're seeing, look at the planet. This is between the rings and the planet's surface or atmosphere, looking out. We've never had that before. So that is just amazing, the fact that we have that. And this is actually one of the Jovian moons, Io's shadow over the surface of Jupiter. Again, these are all pictures taken from the Juno spacecraft. We've never had anything take this kind of detail. And then we have Jupiter looking from the South Polar region. That is amazing stuff. And what the heck? It's Jar Jar Pickles. Okay, Jar Jar, out. Okay, remember Jar Jar is from the Star Wars universe? Yes. Apparently he's hanging around Jupiter. We're wondering where he's been going. Okay. All right, I think that's and apparently I'm getting Facebook messages while I do the show. Whoops. All right, folks. That's the last of the photos right there. Okay. We do a little thing here. Okay. So in January of 2021, NASA extended the mission of the operations of Juno to September of 2025. In this phase, Juno began to examine Jupiter's inner moons, Ganymede, Europa, and Io. A flyby of Ganymede, which you saw in an earlier picture, occurred on June 7th, 2021. That's where that picture of Io came from. Or Ganymede, excuse me. It's amazing close-up photo. Now, let's see here. It came within 645 miles of the surface of Ganymede and is the closest any spacecraft has ever come to the moon since the Galileo spacecraft in the year 2000. Then a flyby of Juno is expected to occur supposed to occur at 2022 at a distance of only 200 miles. And I believe actually that's Ganymede, Io. And then the spacecraft is scheduled to perform 2 flybys in 2024 at a distance of 930 miles. These flybys will further help with upcoming missions, including, this is cool, NASA's Europa Clipper mission. Europa. It's going to land on Europa. And as well as the European, the only other moon we've ever landed on is Titan around Saturn. And that was amazing. That was, remember it was the Huygens probe. Look that up. That was amazing. We actually got pictures of the surface of like methane lakes and stuff on Titan. All right. And amongst other the upcoming ones is the European Space Agency, also the ESA's Jupiter Icy Moon Explorer. I don't know much about that, but just infer the name from this one. Also, the Io, which has volcanoes, Io's Volcano Observer. This is going to beat the Hawaiian National Park and the observers over Hawaii because they're space volcanoes. All right. Juno spacecraft has successfully entered orbit around Jupiter on July 4th, 2016. And for the first year, it will be able to peer below the dense clouds of Jupiter to answer the questions about the gas giant and the origins of our solar system. Juno's primary goal is to reveal the story of Jupiter's formation and evolution using long-proven technologies on a spinning spacecraft placed in elliptical orbit. Juno will observe Jupiter's gravity. Okay, Jupiter's gravity, and as well as its magnetic fields, which it's already doing. We've got some fabulous information for it, and there's more to come through 2025. So cool stuff. All right, on to my thing that I am totally geeking out about. Let me get it up, queued up here, folks. Let's see if we have any questions yet. Space canoes. Yes, Maya. Also space canoes. If I could, I would. But remember, when I said Titan has methane lakes of methane and rivers of methane. If you're European, they say methane. USA, methane. Theoretically, I could kayak on those methane rivers. Considering how cold everything is, and I'm a desert rat that lives in India, tempting, but I need to wait for the technology to prove. And I'm just not really thrilled with the idea. But it would be pretty cool. Space kayaking. All right. Let's see if we go on here. Now, we're going to get on the subject that I have been geeking out about, folks. We're getting on to a big deal that is really kind of 20 years in the making. We have, let me get it up. So many buttons. Here we go. And the James Webb Space Telescope. This is cool. Okay. The James Webb Space Telescope was developed by NASA with contributions from the European Space Agency, also in short, the ESA, and the Canadian Space Agency. Yes, Canada's a space agency, and they do really very well. It was launched originally on December 25th, 2021, just a couple of weeks ago. The space telescope is a big deal. Let me just do a quick thing here. I got to get the slide lined up. All right. Okay. It was actually launched originally in French Guiana by the European Space Agency by an Ariane rocket, and I will cover a little bit later why, because it's the scale of this thing. New technologies actually had to be invented for the telescope to work. It is the successor to the Hubble Space Telescope and is 100 times more powerful than the Hubble Space Telescope. And over the last 30 years, we're all probably pretty familiar what kind of pictures Hubble has taken, which has been amazing. Now, I'd like to point out when I say point out now that the Hubble Space Telescope and the James Webb Space Telescope are actually very different from each other. Yes, they're telescopes. Yes, they can see, bring in those far objects closer so we can see very, very distant objects in the universe, but they do it in very different ways. The Hubble Space Telescope is designed to see visible light. And that's the way it's designed. And unfortunately, when it does that, it can't see things like through nebular dust clouds, like towards Sagittarius A, which is the giant massive black hole at the center of the Milky Way galaxy. You can't see it because the dust in the way. The dust blocks the visible light. So that's kind of a negative thing about Hubble, even though it's taking so many amazing pictures. Now, the James Webb Space Telescope actually sees in the near infrared. Okay, let me get it up here. It sees in the near infrared, which gives it the ability to see through dust in space that Hubble is unable to see. Okay, a couple things. Now, when I said that the James Webb Space Telescope is 100 times more powerful than the, let me get it up here, hold on a second, than the Hubble Space Telescope. Let me give you a good example of what that means. That's close enough to see a bumblebee on the moon. But we can't put a bumblebee on the moon because it needs a spacesuit. Hence, we did that. We're very conscious of animals in animal safety on Late Night Craft Talk. All right. Another part is near infrared. If you don't know what near infrared is, let me go to a bit of pop culture to teach you. Think the heat vision from Predator. I like to try to imitate that. Okay. Excuse me. Now, let me show a diagram of the James Webb Space Telescope. Oh, the mirror. Okay. Let me go back just here and bring back the diagram. Now, there's a few parts to this. Now, the telescope's primary mirror is let's see here. Hold on. Okay. The telescope's primary mirror is the optical telescope element, which you see right over here. That's the optical telescope element. Consists of 18 hexagonal mirror segments made or plated with made of gold-plated beryllium to create a 6.5 meter or 21.4 inch in diameter. Each mirror is that diameter, and it is beryllium is actually very stiff, hard, lightweight metal that's often used in aerospace because it is non-magnetic and keeps its shape accurately in a ultra cold environment. And we're about to learn just how cold it's going to get and why it needs to be done that way. The gold plating actually provides infrared reflectivity as well as durability. This thing has to be durable. And as we go along, you're going to start appreciating those facts. Now, to get onto the mirrors, let's get on the mirror size. Past the B, past that. Okay. What you're looking at is Hubble's primary mirror and the James Webb Space Telescope's mirror. The primary mirror on the James Webb, we'll call it the James Webb JWST. The primary mirror on the JWST is 6.5 meters in diameter, compared with Hubble's 2.4 meters. Think 6.5 meters is basically about 26 feet. And you can see and compare it from Hubble right here. Let me get the squeeze. And those of you that are familiar with Princess Leia, Savea's cute little chihuahua, Princess Leia, that's how big Princess Leia is compared to these mirrors. Let me get, okay. There we go. All right. So that gives you the idea of the scale of this thing. And we launched that up, but it wasn't easy. And it went up and it went folded up. Okay. To make observations in the infrared spectrum, the telescope must be kept under negative 370 degrees. Let me get that next slide. Okay, under 370 degrees Fahrenheit. Otherwise, the infrared radiation from the telescope itself would overwhelm its instruments. It's that sensitive. It uses a large sun shield to block light and heat from the Earth, the sun, and the moon. The shielding maintains a stable temperature for the structure on the dark side, which is critical to maintaining precise alignment of the primary mirror segments in space. So let me get a little thing here. If you remember, a lot of you are old enough, when Hubble launched back about 30 plus years ago, its mirror was messed up. It was slightly misaligned and it created fuzzy vision. It was close enough in orbit around the Earth. They were able to send the shuttle up 340 miles to Hubble, which is amazing. It got that high, and had to put adaptive optics on it. Basically, it gave Hubble a set of glasses, and then we're able to see. We don't have that opportunity with the James Webb Space Telescope, and I'm going to cover why here real shortly. One, because there's ain't no way we're going to reach it in orbit, because it's going to be about 1 million miles out, and it's slowly heading out there right now. All right, everything about the WJST, I might mix that up a little bit. Remember, I can't even remember what the T and the E stands for in STEM, but I know things because I'm smart, or I pretend to, and I pretend to be smart on the internet. All right, everything about this is massive. Okay, let me get a little diagram up just to get a scale of this thing, just how big it is. It's as long as a tennis court. That's just the sun shield. And I already talked about the 26-foot mirror once we get all come get folded together. Let's see if we got any comments. Yes, mine, it is rad. It's pretty amazing. All right. It's the size of a telescope once everything's fully deployed. Okay. I'm going to show you some pictures of the James Webb Space Telescope under construction. Here's an idea of the scale of this thing. Look at that cherry picker off to the left. Look at the size of the mirrors and the size of the guys working on that lift on the right. That's how massive this thing is. It's huge. And here's a close-up of the hexagonal mirrors. They're gold-plated beryllium. These are just amazing. This is the sun shield. We're going to learn a little bit about that here in just a few minutes. And also, apparently, in the picture is John Travolta in the lower right. All right. John Travolta snuck into our show again. Apparently he was involved. 1990s Pulp Fiction. John Travolta was involved with the making of the James Webb Space Telescope. Let's get moving. Okay. Here's another picture of the sun shield that you saw in the illustration, the diagram, starting to be installed, put in there. We're going to learn a bit about that. We'll briefly cover that. And here's this thing folded up. Now, we didn't launch it in shape. It has to be unfolded. So it has to be packed up into this giant package right there, put in a tube, and then shipped off to French Guiana to be put on top of an Ariane rocket. This is pretty amazing. Okay. Let me end the screen here. Okay. Hold on. Okay, there we go. All right, now, this thing is so massive that the only rocket available was the Ariane rocket from the European Space Union. It has what's called a fairing, which is the very top of the rocket. When you see launches and those things go up the top and the satellite goes, that's the fairing on the payload bay of the Ariane rocket. The only thing big enough to launch this thing up with the payload fairings was the Ariane rocket. Hence, European Space Agency went down, French Guiana, that's where they have it, over at the top of South America, right above the equator, and that's where they launched it from. There's a lot of physics reasons why, and the rocket just, like I said, it had a big enough payload. Okay. Now, when this thing goes out, it will not be technically, it's not technically orbiting Earth. It's actually going out to a point beyond the orbit of the moon to an area about 1 million miles away that I mentioned a little bit ago, to an area called the L2 Lagrange point. All right, now we're going to start sounding real smart as we go along. Okay, let me get that. Let me get a diagram up. Okay, that is the Lagrange point. It's basically an area where the sun, the moon, and the Earth's gravitational fields cancel each other out. The telescope will be pointed away from the Earth, the moon, and the sun. It'll be pointed outward, as you can see in that graph toward the bottom. When you start looking over a bit to the right, it'll be pointed away from, like I said, the Earth, the moon, and the sun to maintain keeping its instruments cool. And that's why the sun shield is there on the underneath part to help protect it from solar radiation from overheating. So that's there. And the sun shield itself is an amazing piece of engineering. Okay, what we're going to look at now, show the video. Okay, what we're going to look at is a video of the deployment of how this thing's going to unfold. Right now, it's currently out. It's like halfway out to the L2 Lagrange point. And just so you can smart, if you ever you're in a conversation with anybody, take notes on what you see right here, because these are the other Lagrange points. One of them being on the completely opposite side of the sun. Okay, this is the deployment. Watch this incredible $10 billion piece of origami. Two hours after deployment, when the solar panels actually went out, you can see that on video. Now this is the sun shield coming out. This is the telescope, the actual primary mirror deployment. And see where look where the mirrors are right now. Okay. Momentum flap, I don't know what that does. All right, the sun shield, as you see it being unfurled, there are so many mechanisms. I don't remember the numbers, but there's basically hundreds and hundreds of moving parts to make this happen. And the sun shield's actually not deploying that quickly, what you see. It's going to happen very slowly, because if it happens quick, it'll oscillate the spacecraft and possibly make it twirl, and that's a bad thing. What you're seeing is actually done by now, and it comes in 5 layers that you see. And we're actually at the part now where we have the secondary mirror that you saw deployed. And now comes the mirror deployment. Pretty amazing. Yes, it is gigantic. Orbital injection burn. That's where it reaches the Lagrange point. And y'all remember what Lagrange point is, because y'all smart now. Well, smarter. The knowledge. Okay. That's a deployment video. I didn't want to take that because I didn't want to do a lot of videos, but I felt that was really important to get the idea of the origami of this thing unfolding. It's like I said, it's a $10 billion piece of origami. The major engineering challenges and compliments of being able to have the telescope fold up to fit inside of the Ariane rocket and have it slowly deploy its sun shield and primary and secondary mirrors while it takes its 30-day journey out to the L2 Lagrange point is just amazing. It's an amazing exercise in remote origami. This thing was 20 years in development and was originally supposed to cost $1 billion, but went to 10 billion. It's so revolutionary, as I stated earlier, that new technologies had to be built, had to be invented and developed for this thing. And if something was slightly wrong, it would go get tested again. I can't imagine all of those of you that are space enthusiasts, just like me, were probably getting very frustrated that it was delayed again and again and again and again over the course of 10 plus years. And even this year was delayed twice because of some little fallacy. But once it launches, there's no fixing it like Hubble. Once it goes out there, we got to get it right. We can only get it right once, and it's the first time. So pretty amazing. All right, let's get some cool other stats. We're getting toward the end of the show. All right. As of today, as I kind of covered, as of today, the sun shield is fully deployed and the secondary mirror. Once this telescope reaches the L2 Lagrange point, it won't immediately be able to make observations, but because it's going to take about 6 months worth of testing by NASA to make sure all the instruments are working, everything's flying, that the software is there. Because once it gets there, it's probably going to have a software upload, just to get things working. It's NASA moves very slow, very cautiously. That's why NASA has one hell of a track record. Okay. Now, what exactly we'll see when the James Webb Space Telescope comes online, it's figuring about June of this year. I can't wait. What we see, we won't know. We can only imagine. And with that, I want to bring up a photo, actually, incidentally, from Hubble. And this will make a cool closer. Now, I'm going to bring it up here. Let me get it queued up. All right. What you're seeing for perspective, this is called the Hubble Deep Field Image. For 10 straight days in 1995, Hubble stared at a tiny, nearly empty patch of sky near the Big Dipper. The telescope actually gathered all the light it could, slowly building a picture. And what emerged is what's called the Hubble Deep Field. It's revealed galaxies fainter than have ever been seen before. The light from some of these galaxies have traveled for 10 billion years to reach the Earth. This is said to be one of the most important pictures ever taken in the history of the human race. We're looking almost all the way back to the beginning, to the Big Bang. And that's amazing. Now imagine what the James Webb Space Telescope, with the imaging power 100 times that of Hubble, is going to see out there in the near and just in the near infrared. It'll reveal the origins of the universe. And just, you know what, we're going to go ahead and let's zoom in on this picture just now as we have it, and let's see how far we can make it in there. Let me bring it in, folks. Let me do a little software upgrade just so we can see it. Let's see what we can see far back. And by the way, something cool about this picture. Oh, okay, we're starting to zoom in. We're starting to zoom in. All right, we got to zoom in there. All right. Neat tidbit here is that what you're looking at with these galaxies, you get an even closer bit of there's over 10,000 galaxies in this photo. We're looking at the windows of time. This is like looking, say, at an elephant that's currently living. And then 20 feet behind that, because, we're looking further back in time. We're not looking at everything at the same time. Looking at an elephant, then a mammoth, then a dinosaur, and then, like, say, a giant insect before that. We're looking back. Imagine standing there and seeing all those creatures. You're seeing one from the distance, one behind the other. That's what we're looking at. Galaxies are more development than the others. And let's see if we can zoom in just a bit more and see what we can see all the way back to the beginning of the universe. And apparently the beginning of the universe is with Baby Yoda. All right. That was unexpected. Oopsie. That was supposed to happen. I pressed the wrong button. Okay. Well, Let me stop sharing. Stop that little faux pas. Okay. With that, that has been tonight's episode of Late Night Craft Talk, the STEM episode. Let's hope Savea gets better. Y'all put Savea get better in the comments right there. We want to hear from you. If you have any questions, put some comments right now, because I'm going to be just doing our final graphics here for the show tonight. Let me get her going. Pressing spacebar till we get to where we need to go. So many pictures we shared tonight. We shared a lot of amazing stuff tonight, folks, because y'all are amazing and we're amazing together. We make some great stuff. All right. The show should have been 2 hours. So much information and things to learn about. Yes, Maya, indeed. Matter of fact, I know that I will be getting, I have viewers that actually will message us after the show. They really don't want to, they're kind of shy to type comments during the show. Those of you that do, we're feed off you, but we're here to spread information, and I'll get a lot of questions after the show. I'll probably shoot out a few emails tomorrow about this with asking information. I know that Savea was looking forward to this because she enjoys this probably more than I do. Especially she liked the graphic comparing the size of Princess Leia to Hubble's mirror to the WJST, got it, telescope mirror. So it's worth a lot of chihuahuas, the size of that mirror. Yeah. All right, folks. Let me go ahead and introduce next week's subject for the show. We're going to go from space to poetry. On next week's show, we actually have a guest coming on. We're going to have Tabitha Smith, the emerging native artist. She's going to be sharing some of her poems, as well as Savea and I are going to be coming up with some poems about the show and just, fun stuff in general. So, yeah, we're going from science to poetry, from the art of the universe to the art of the word. And both are still powerful imagery within the mind's eye. All right. With that, let's see if we have any comments to cover. Wow, I'm actually into the show at 11 o'clock. I thought I'd run long tonight, but just been cruising along. Okay. So let me get a couple things here queued up, see if I got anything else in the notes. Nope. All right. We got any comments? Yes, I learned a lot of stuff you would never think about. Thank you for the amazing show. Thank you, Maya, for the compliment. Let's see if we got any others. Nothing at the moment. So with that, folks, this has been another episode of Late Night Craft Talk. Hope you enjoyed the show. This is one of our STEM episodes. Usually we have Curtis Youngberg come on, but he is not available right now. Curtis, you're watching the show. Man, we got to get you on. One of you on this show tonight, but we'll have some other STEM episodes coming up. So after this tonight, folks, go out, look at the stars, see what's up there. Look up, wonder, and know that we're sending spacecraft, but even take your mind, learn, and explore. This has been another episode of Late Night Craft Talk. Y'all awesome. There we go. Things clicking. We'll see you next week. Poetry episode next week. Cue tap dance. Aw, ain't he cute?